Good morning, good evening, everyone. Welcome to the HATO Insights webinar. Thank you for your time, for being here, and for your interest in this topic about lighting. Today, we will be talking about understanding animal vision. We have started this year with a series of webinars related to lighting for livestock. And in every session, we will talk about a different aspect of lighting or the photobiology of the animal. Last time, it was about light spectrum and CCT. And today, we will focus on animal vision, mainly for poultry, cattle, and swine sector. In any case, if you have any question about any other species, leave it in the chat box, let your comments in there, and we will be more than happy to help you further and answer your questions. It is also important to check where your control bar is, sometimes at the top of the screen or the bottom of the screen. And there you can find the chat box to leave your comments, because it's the only way to get this webinar interactive. So leave there your questions. At the end of the presentation, we will leave some room to read these remarks or questions or comments that you get along the presentation. We will also put some polls along the presentation, so we really ask you to participate on that, because it is important for us to get your insights as well. Okay, so people is joining. We have a good number of assistants or attendees right now, so we can already start. Today is with me Jacobin Visser, Livestock Research and Data Analyst. Hello, Jacobin, good morning.
Good morning. Hi.
Yes, you can introduce yourself a bit. Yeah.
Yep.
We hear you loud and clear. Yep.
Yep. So hi, I'm Jacobin Visser. I'm researcher at HATO, and I look into what effect our lighting has on the animal welfare and on the production for agricultural lighting.
Okay, thank you. Well, my name is Cristabel Huerta, brightness consultant at HATO. I'm the one sharing knowledge, the HATO insights, and what we have gaining in experience and research and studies, and working together with people from the sector. All this knowledge we love to share with you, with our partners, with customers, with end users, just to bring the awareness and the importance of a good light climate in livestock farms. This with the mission of getting a more sustainable farming and responsible farming, looking for the animal well-being, and as well to get better farm results. So let's start and have a short introduction of HATO. For those that know us a bit less, or if you just have heard about it in the market. So we are not new. We are now celebrating our 50 years anniversary, while bringing a lighting solution in livestock farms. Our tagline is the essence of HATO, improving life through brightness, meaning that we come with this continuous improvement and development of bringing lighting solutions for the different sectors, poultry, cattle, swine sector, also for mushrooms. These solutions which are very resistant, robust, and that last long in extreme environments. So that is very important for a farmer. But the most important is to understand the needs of the animals, and to fulfill those needs, to get the right solution for the type of house, your application, that the animals are really getting the lighting in the best way that we can influence their behavior. And with that, you will see a change in performance if this is optimal, and get better results, because the idea is to increase productivity. Okay, let's continue. We will start with a poll. So while I'm launching the poll, Jacobin will read the question and the options.
Yes. What do you understand by animal vision? Only one option possible. A. All animals see the same way but different than humans. B. Animal vision differs per species. Or C. Vision differs only per light source type.
Okay, so it has appeared on your device. You may answer the question. All right, so majority has answered, so I will end the poll by now and share results with you. So majority answered correctly. So animal vision differs per species. The last option C, vision differs only per light source type. It's a bit tricky because it's not only. So the vision differs per species, so how the perspective is of that light spectrum, and also might differ per source type, meaning that the perception of this light spectrum could be different under daylight, under fluorescent light, or LED. Okay, so we will learn a bit about it along the presentation. And we'll go to the next one. So, but to understand that better, we need to understand what is light. As definition, it is the visible part of the electromagnetic spectrum, so the color vision. So as you see here in this graphic, it is the visible part that comes in between the ultraviolet rays and the infrared rays. So that is the visible light. And that is what we perceive as daylight, the white light. And this white light is the combination of all these colors or the different wavelengths. So the wavelengths, every wavelength is a different color. And it goes from short wavelengths, so here measured in nanometers. So from the 300 is in the ultraviolet rays, and then it goes wider until the infrared rays. And we will see that these colors of each color has certain influence in the metabolism of each animal and in different ways, depending on their biological process. So if we will take a capture of daylight, you will see it like this, as a very wide spectrum, which the visible part is only this. So if we want to have an optimal light climate in the farm, we need to try to simulate daylight. So in a farm with a completely climate control, which is completely closed, then it's even more important to choose for the right solution that is giving you a wider spectrum of light. So with all colors that it is needed for the good development and growth of your animal, and also that can influence in their day-night cycle, and as well in their performances. So with that, having in mind that you need to simulate daylight as well, to simulate sunrise, sunset, and to be able to dim light intensity, that in order to decrease stress and increase their well-being, the animals will perform better and more at ease. Okay, so if you have also houses with daylight entrance, but you need only supplementary light in the farm, well, try to look for to fulfill the needs of the animals. The way that we were explaining in the previous webinar about light spectrum and the color temperature of the light, we will see how now these two topics are related as well with animal vision. And we will go more in specifications in the photobiology of each species. Okay, so we will start how poultry perceive light. So it goes through the eye, which is under 4 looks that eyesight is of greater importance for behavioral responses and the day and night cycle. And above 4 lux, light can penetrate the skull, and this stimulates birds sexually, so the long waves, which is more focused on the red part of the spectrum, as we saw in the previous graphic. And that will also help you to improve egg-laying performances, such as egg numbers and hatchability. Both these two ways that poultry perceives light. And poultry is one of the animals that is more sensitive to light. As we see here in the graphic, the pineal gland is like this light sensor. So besides the eyes, that they can see light, they can also sense light through the pineal gland. And that is what influences the metabolism. And the retina of the eye is composed with rods and cones, where rods is what sense light movements, and the cones what see the different colors. And humans, for instance, can process around 25-30 images or frames per second, while the birds, it's around 150 to 200 images per second. So they see more than us. And also their eyes are so sensitive that they can see tiny light fluctuations that are imperceptible to humans, meaning that poultry is very sensitive to flicker. Perhaps you have heard about this aspect of lighting that can cause a lot of stress, because they can perceive this difference in light, fluctuations in light intensity. So that is why we need to understand better the aspects of lighting, but also animal vision, depending on every species, to build an optimal climate in the house. We see as well here that chickens have a panoramic vision of 300 degrees. So birds are able to move each eye independently, and that poultry eyes process more images per second. In the next slide, my colleague Jacobin will explain you more about this physiognomy.
Yes, so we have already heard that the cones provide us with the color vision lights. We humans have 3 cones, which are the red cone. We normally prefer reference it as a L cone. Green color, the green cone, which is referred to the M cone, the mid wavelength cones, and the blue for the short waves. Chickens have 4 cones. So as you can see on the graph, the poultry have also a red cone, a green cone, and a blue cone, which already differ a little bit in comparison with the human red, green, and blue cone. But they also have a UV cone, which is the purple one. The black one is also for other type of birds, but that's not for the poultry. So in the picture below the graphs, you can see a compiled spectrum, which we think that humans with the, sorry for the extra sound, which the birds can see. And if you go to the next slide, yes, we can see a picture in which we the colors of a bird are perhaps seen as by birds' vision. So we cannot see into the UV light, but we do know that it will that some of the feathers will provide more light back. So they see it as a different color, and it is an interpretation of how birds might see other birds.
Yes, so therefore it says in the markets that UV A can be beneficial in poultry farms, because birds can see under UVA, and that even they can identify a feather pattern. And we see that in this graphic. The perception of this light spectrum is broader that with humans, where we do not see under UVA, and they can have this perception. Okay, so how do pigs perceive light? They have a panoramic vision of 310 degrees. We see here the monocular vision is quite wide. They have a blind spot in the back, and the binocular vision is shorter. And that is why they have a difficulty to estimate a distance And therefore, we need to provide enough lighting that goes to the ground, to eye level of the animals, so that they can perceive better their surroundings, so that they don't fall, or they don't go with other animals, so that they can find feed, water. That is very important, so that the light that goes through the eye, and that they can feel at ease, less stress. So that therefore it's very important to improve vision. Now, how does cattle perceive light? Well, they have something similar like in pigs, a panoramic vision. It's wider at 340 degrees. They have poor depth vision due to the small binocular vision. They perceive, well, lower light intensities than humans. We'll see in the next slide. Well, here is also important that you give enough light intensity. Sometimes in cattle farms, we see that they have enough daylight entry, but it's not getting sufficient light to the ground where they need to go to stimulate for feed intake. And then we will see at later on the presentation that light intensity is very important to improve performances in the farm. Here, Jacobin.
Sorry. Yes. So cattle have a unique type of layer behind their eyes, which is also known for in cats and dogs, for example. They have a tapetum lucidum, which is a film in their under the retina, which reflects lighting, and that makes it possible that the cattle can get more triggers. The cells are triggered more due to the reflection of the tapetum lucidum. So the cells, so the eyes are capable of getting even the cells, the cones triggered in lower light levels.
Exactly, that is very well explained. Also, important to mention that, for instance, in poultry, they have poor vision in darker environments. Also, you can have very low lux level, but just be sure that the light intensity is really reaching the area that you want to stimulate certain behavior, because otherwise they will not recognize their surroundings or environments, different from cattle, for instance, that they can adapt better their vision under dark environments. And that is what we see with certain animals. Okay, and that is also different from humans a bit because for us under dark environments, so we can adapt to it, but it takes for us a bit longer to start seeing our surroundings. Okay, so that is by understanding better the vision per species. All right, Jacobin.
Yes, as we have seen in the poultry, where they have 4 types of cones, pigs and cattle only have 2 types of cones, and that is both the blue and the green one. In the next slide, you can see an interpretation again for how animals perceive the following. Yeah, so because they don't see the red color, or they cannot distinguish reds from greens, it is a more reddish, a greenish bluish color of world they are living in. That doesn't mean that red light is not perceived. It is only not perceived as a red color, but the green cones still see some in the red part of the spectrum.
Exactly. So there's the difference that still the red can have certain influence in their behavior, but they do not see the red color from as a color from their eye. Okay, here we have another poll.
Okay, the poll. Do the animals perceive the same environment under 2 different light spectra? Only one choice possible. A, yes. B, no. Or C, it might change. And the same spectra is with under 2 different spectra with the colors with the spectra which are on the right side of the screen.
Yes. After people has answered the question, we will explain a bit. Okay. Okay, so majority has answered. I will end the poll by now and share results. Right, so a bit more than half has answered no, which is the correct answer. So animals do not perceive the same environment under two different light spectra. Here we even having an example within two LEDs light spectrum. At the beginning, I was mentioning as well that it's not the same how the animal will perceive their environment under daylight or another light source like fluorescent or LEDs. So that is very important to keep it in mind. All right, so Jacobin, can you explain, please?
Yes, so as we have seen, the cones differ per species. So chickens have already 4 cones, cattle and pigs only have 2 cones, not in the red part for the pigs and the cattles, pigs and cows. So in these two spectra which you see, there is a high peak in the left one, which there is a more greenish blue, greenish reddish big peak in the right one. And although for humans it's the same CCT, the CCT is only a human-based calculation. So the variation of the cones, the types of cones, make it that it is a really completely different light type for cattle, pig, and
Poultry.
poultry.
Exactly. So here we are seeing the CCT, which is measured in Kelvin degrees. For those that would like to know what CCT means, it is here 2,500 and more into the well, even higher at that the Kelvin degrees, taking into account that is a bit similar, but then the spectra is different, and also the perception will differ per species. Animal vision. Jacobin will explain this one.
Yeah. So we have already talked about what type of cones they have. So we see that there is a difference in the number of cones they have. Poultry have 4, humans have 3, and pigs and cattle only have the blue and the green one. And this is also depicted in the picture on the right side of the screen. But it is not even only just the types of cones we have. It's also the distribution in the eye that we have. So as humans, we have a really a high color vision, but mostly the reds and the green in our main eye site, and the rest, the blues, are a little bit more on the side, and the rods are not even present in that. So the rods, which is the light sensitive cells, are not even in that one. That also makes it that whenever you look at stars, you cannot see stars if you're looking at directly at them. But if you just move a little bit to the side, the rods are then triggered because they are on that part of the side, and you can see stars, for example. The distribution of the cones is also different between the species. So, like I said, as humans have a really specific place, which is the fovea, where we can see really good colors. For chickens, it's mostly the whole retina is filled with color sensitive cells. So the L, the M, the S, and the UV cones. For sheep, we have here taken the sheep and not a cattle, because it was not in this scientific paper. But the sheep and the pigs have both a horizontal line where there are more cones in comparison to the lower and the higher part of the retina, which is depicted in the round circles on the right. So we have the distribution of the cones, but we also have the amount of cones. So the more the amount of rods you have. So the more rods you have, the more light sensitive you are. And with sheep and with cattle, even the tapetum lucidum benefits the light sensitivity even more. Not only is can we look into the retina, but we can also look to the shape of the iris, which, for example, in sheep, is a horizontal line. Because they want to scan the whole environment, and they have more focus in that, and the lower and the top of their vision is a bit more blurry, because it doesn't really matter what's happening there, they really want to see the horizon. So all these things together make it that that animal vision is really different. And then we have not even looked into the critical flicker fusion, which is very important whenever we look at light that flickers, for example. So as humans, we can see we have a critical flicker fusion, which is the frequency of which we cannot distinguish two images as independent images, but as it will become fluent, like a movie. We humans can see up to 60 hertz, where sheep can see up to 80 hertz, and poultry can even see 200, even 120, 150 hertz sometimes. So that's why flicker is really a problem in the poultry sector.
Yes, exactly. So it is important when we mentioned on these aspects of light that so far we have been talking about light spectrum, CCT or color temperature, which is measured in Kelvin degrees, and now flicker-free light intensity and light distribution, and even another more that compose an optimal light climate and really need to fulfill the needs of the animals. Okay, so here we have another poll. I will launch it.
Yes. How does light intensity influence the animal behavior and performances? A. It doesn't have any influence. B. Stimulates desired behavior at different light intensities. C. The higher intensity, the better. Or D. Increases productivity.
Okay, people is answering. So you are seeing the question on your device. All right, majority has answered. I will end the poll by now. Yeah, everyone answered. Thank you. And share results. So people, majority answered correctly. It stimulates desired behavior at different light intensities. There are other options that we know definitely that light intensity really influence animal behavior. And then therefore we can think about lighting to be a tool, an extra tool. So not only a part of the equipment of the farm, but really a tool that can help you to manage your flock or your animals in the desired way. Depending on the challenges or issues that you are having in the farm, what you can bring into benefits, light certainly can contribute to better productivity and better performances. So now we go to the next slide. We will talk more about light intensity. So that is really having the correct usage of light intensities that can stimulate natural behavior, but being sure that all factors are related to light intensity, same as photo period, depends on the type of house, location, breed, and other things, characteristics in the farm, or the challenges that you are looking to bring into benefits in order to have the right light intensity. But for that, you need to be sure that it is coming that light intensity into the right place of the house. And that you can do by measuring the lights. So underneath the lights, in between the lights, in the middle of the house, closer to the feeders, drinkers, depending on the systems that you have in the house, the application, the breed, of course, what the light management of the genetic line is also telling you. You need to measure it, and then you will have the lux levels. But remember that the lux level is based in the way that a human perceives light. From the species that we were talking here today, poultry is the more sensitive to light, and therefore there is a specific parameter to measure light intensity, which is Gali lux. And those values will be always higher than lux values because, as we have seen here, poultry is more sensitive to light. So it will be also an advice just to have a reference how is really your flock or your poultry perceiving that light intensity. That perhaps on your mind or you are measuring in lux and in Gali lux are getting a completely different levels of what you're thinking you are having in the house. Even when you are comparing two houses that are quite the same, you can get different values in there. So adjust the lux level also to the different areas in the house where you want to create more illuminance, more activity, or that it has to be darker to get the animals more comfort, to feel more at ease. Or for instance, in floor housing, when to want to reduce floor eggs, that you have to create darker areas close to the nest. Lighting is also the tool to start training your birds to use the system correctly. That you will see it in floor houses and aviaries. Also different zone of lighting that can have this differentiation in light intensity that will influence their behavior, and it will still stimulate a more natural behavior. That is also, we will see different examples in cattle, pigs, and poultry. Which is very important, and that light intensity is related to a good light distribution. Okay, that will create a comfortable environment for livestock. And a good light distribution means the right amount of light in the right area in the house. So we look for uniformity, but doesn't mean that it has to be the same lux level in the full house. That depends on the broiler, also on the type of housing, also the regulation of the market, because that changes per regions. It's not the same what North America or Europe or in Asia are doing. So the practices are different, but we need to try to fulfill the needs of the animals and know all the characteristics of the farm, just give the right light intensity in the right area of the house. Here are some benefits that you can reach with good light climate. Stimulate feed intake to reduce stress, so no more starkling caused by bright spots or shadows that stimulate fertility and stimulate production. Also, the mobility is another important point, and therefore LEDs are very beneficial when building an optimal light climate, because a good LED lighting solution can be dimmable even from 100 to 0%, to have a deep dim curve that is steady without flicker, because we have seen that animals are also sensitive to that light fluctuation, that flicker that can be perceived as a threat, certainly in poultry, and that increases the stress. Dimmable lights also stimulates dusk and dawn, which stimulate a more natural behavior. And with that, you can also get more desired behavior, improve well-being. Animals are more at ease, will perform better, and you will see certainly improvement on FCR. Here I want to show you a short video on how the birds can be trained to use the system correctly in an aviary.
As you can see in the video, we use Corax main lighting and Bubo system lighting from HATO. By sequentially dimming the Corax main lighting and the Bubo system lighting, we train the birds to go into the system at night. The learnt behaviour from the bow leg starter rearing shed causes the birds to react exactly to the HATO Corax litter and Bubo system lighting within the laying shed.
You see that we are having main lighting in the house, and also lighting in the system and underneath the system to control the birds, or to manage the flock accordingly what you want to reach, so that they really go into the system, that not any bird gets in the floor, that to avoid floor eggs, and that you can also manage the lights apart, to turn off the main lighting, so you get only the light in the system, and then underneath you turn it off, and then after all, then the light inside the system, or the perch light.
As you can see in the video,
here also a nice picture of what we mean of having the right amount of light intensity in the house. We see here before that they were having some lights in there, but the light intensity was not really reaching the ground and lower lighting densities. So it was well lit, but not in an optimal way. And it is really essential that light climate is optimally adapted to the housing type, and also according to the animals and how do they perceive that light. So this one, you'll see that is more bluish, so certainly a more cool white lights, because cattle has these two cones, the blue and the green, which they will perceive better their surroundings, and with higher lighting densities, and you get a nicer environment. Where with independent studies, they have seen that with more light in the house, they can have an average increase of 7.62 in milk production. And this is only about lighting density. And there are studies done since 1989 to 1997. And we have also a white paper that you can find in our website with a complete research done within HATO, and where we see this increase only by having higher lighting densities with white lights, with cool white, which is the best for cows, the way that they perceived light, and also adding another color, which also influence their behavior and stimulates their metabolism. So it is also very interesting to get to know more about it. In the next webinar, we will also talk about color lighting, and there we can go more in depth about this topic. Peak lighting, here we see as well another independent study where we see a house having only some windows with a daylight entry in there, but in certain areas it was very dark. So you have these brighter spots, darker spots, and there was also not uniformity in performance. In this graphic, yes, perhaps quite tiny, but what it says in here, that in this period of time from 2014 to 2017, they have seen a decrease in productivity. This is about the weaning to first service interval, which is a parameter which can be measured in pig farms to check on productivity. And that period was reduced from 9.9 days from 2016, exactly in the winter period. There was a farm in Spain, to 6.2 days. And in 2017, by just adding more lamps in between those spots to create a better light environment and higher lighting densities, they could decrease to 3.7 non-productive days. And each non-productive day costs around 2.2 euros. And this farm has about 50 weanings every week. And in 3 months, the farm saved around 3,700 euros just by installing supplementary lighting, reaching the correct lighting density that is also going to the stimulating the animals accordingly, and improving light distribution in the house. Here's another example of what an optimal light environment would be in this type of housing with pens, when you want to stimulate the sows to fertility as well. So you have your main lighting that can be a less number of lamps, but you need to have higher lighting densities and above the head of the sows so that they can do the right stimulation. Therefore, it is very important where you will install your lights and which would be the design to get the most luminosity and the best distribution of lights according to the application and the type of house. So we have coming to the end of the presentation. Just on time, just to give some room of questions, of comments you have been leaving in the box. Jacqueline will help me to answer these questions. Just to finalize as a conclusion what an optimal light climate is, as animal adapted lighting optimally that improves sight and influence desired behavior in the house. How? Well, looking for the right light spectrum, right light intensities, looking for a broad light spectrum that simulates daylight, that will improve sight and improve their well-being, which makes animals feel better. And with that, you will see a change in behavior, and that lighting can help you to manage your animals in the desired way, according to the challenges that you are having in your farm and the specific needs and characteristics of your farm. And with that, you will see an improvement in performance. So lighting can definitely contribute to get better farms results. And when you look for lighting solutions like LEDs, which are specialized to be applied in livestock farms, you will definitely look for a more sustainable and responsible farming. So if you have any questions, so don't hesitate to put it in the chat box or send us an email or contact me directly afterwards. You all will get a follow-up email with some resources of regarding this topic to get to know more about it. We do not upload the webinars in our website, but you are all welcome to join to the next sessions where we always relate a bit of this topic to the other aspects of lighting. Or if you want a specific training or workshop or presentation to be given in the association, organization, or within other teams, we are open to share our insights with you.